Straton unacheka nini?
Brian, Brian. We are resuming right now.
Where are the other guys? I have only 5.
They are reconnecting.
So I will need to get the pro one so that we can be able to, when you hold a class, you just continue up to its completion.
Waiting for the?
There is one which they call pro, that is the Zoom. You need to pay some amount so that they give you unlimited time.
Okay.
This one is free for 40 minutes.
Okay.
So we are waiting for the other members. Still, I think we have 6 more yet to come because we had 12. How many are you in this class total?
Yeah, 14.
14. So there are 2 guys who are not in.
No, one guy, it said you not manage. I don't know. Yeah.
And the other one?
I don't know who is. I don't know who is missing.
Oh, you don't know who it is, eh?
I will not check the list. Let me check. Oh, one person is having challenges. I don't know. She has issues with connection.
Oh, the other lady?
Yeah, the other lady, Christine.
Oh, Christine. She was not able to, we were not able to communicate, eh?
Yeah, she has issues.
Okay.
With her device.
Oh, boy. So how come these other guys are taking a bit long? Because, you know, it takes 40 minutes. And I wanted us to do only this one so that the next time now we will have known our ways around. You guys, you can, we can be able to do our classes properly now. Because today, actually they're still connecting anyway. Today I wanted us to do, you see how it works. And then from there, you guys, you will have known what is supposed to be done. You can actually be able to do more other classes without many issues. Eh?
Yeah.
But I think you are realizing it's not, it's actually a good tool.
True.
Exactly.
It's a good, because even this one now, maybe I'm not writing on the board. After all, even most of what we are doing in your class, I was not writing in most cases, apart from the calculations. Yeah, so this is the same. It's only that now my image is a bit distance away, but you are seeing the image still. The same way you see it when we are in class. After all, it's an image you see in class. Your eyes are just getting a reflection of myself. So it can just be like an actual class in a classroom. Eh?
Yes.
But then when you want to, even if you were to get all the videos, you can actually be able to see all of us. We can be able to appear on the screen, all of us.
Yeah.
So let me start because we are now 9. I think only 3 guys will need to join. And I'm looking at the transfer characteristics. So I think this time I didn't manage to take that image the first time. So let me take. an image very fast. But also you realize that this break can be okay in case you are doing an exercise. Somebody just gives you a break, then you do the exercise, then you come back. So it can also not be a very bad concept to have breaks. So transfer characteristics, we realize it is actually IC versus IB. Please note that VC is constant in this case. And from here, you can be able to see, somebody can describe this graph for us very fast. What's happening to IB, IC when you increase IB?
Can say it's directly proportional. An increase in IC.
No, you start with an increase in IB because IB is what you are changing. Eh?
Oh, okay. So it's an increase in IB leads to an increase in IC.
That's
but
correct.
Then there is a section there that has got. So we have where we have some
ICO.
constant. Yes, ICO.
Yeah, this is what we call leakage current. It's actually called the collector emitter leakage current. It's a collector emitter open leakage current. So usually not very important, but sometimes you can talk about it. So when you increase IB, there's a corresponding increment in IC. Which features can you get out of this? If you look at the graph, there are features that you can be able to get, parameters. One of them is IC divided by IB, which is equivalent to, what is that supposed to be? What is that supposed to be?
Here's my book.
Gain in current.
IC divided by IB, we said is what?
IC.
Gain in current gain.
Please know that it's gain current gain, and we called it beta. It's given that simple beta. And then you also have, we have VC divided by IC. You can see because we are basically dealing with VC at this point. So VC divided by IC gives us what? It's output resistance, eh? And then IB divided by VC should be the same as
Transconductance.
Yeah, it's basically transconductance.
Transconductance.
Those are the parameters that you can get out of this graph. So please note that those are what we call the transistor characteristic curves. That's how they are usually supposed to be. And they're very important when it comes to the analysis of our transistor. So you move on. And usually you need to be able to know some of these concepts that we have discussed about. Don't forget them, because we keep on using them after. It's like you are building on what you have been discussing about. So the common collector we are not doing, and the common base. The common emitter is what we only discuss about. So I will go to the next section, which we call methods of transistor biasing. And this way we'll do a bit of calculations. So we'll be able to see on how to handle them. But please know that methods of transistor biasing. First of all, we understand we need to understand what's biasing. And it's basically a way of connecting your transistor to power. So it's a way of connecting your transistor to power. Or to voltage. And sometimes you'll be using resistors to connect it also, so that it can be able to operate normally. Actually, this is for the purpose of application in amplifiers or in amplification. So there are methods which we have for connection, and those methods are given by, the first one is base bias. The next one is base bias with emitter feedback. The next one is base bias with collector feedback. The next one is the base bias with collector and emitter feedback. And the next one is emitter bias with 2 power supplies. And the last one is the voltage divider bias. Of all these, the most commonly used is this one, the voltage divider bias. We'll be able to see it later. But for now, let's look at each of them, starting with the base bias. And please look at the diagram, the way it looks like. You can see here that we have RB, we also have RC, and we have VCC. Then we have the transistor here. Please know that we have various types of parameters. IB, which passes through the base. IC, which will pass through the collector. IE is down here, though we don't have a resistor. So we just have it passing through to the ground. Please know that from this point to this point is what we call VBE, but from this point to the ground is what we call VB. From this point to this point, we call it VC. From this point to this point, we call it VCE. And from this point to this point, we call it VE. So all our connections that we are going to have later, they will have these same parameters, except maybe 1 or 2, which can have slightly different parameters. So let's have a look at some of the equations that you can be able to get out of this configuration. And are you seeing that from here, go through the resistor here to the ground, you're going to have VCC is equals to IDRB, which means the voltage across the resistor, plus VBE, and VBE is from this point to this point. And that completes that loop. So the other one will be VCC is equals to ICRC, which means you multiply IC and RC, and then you add the voltage across this point to the ground. So that brings us to VCC is equals to ICRC plus VCE, because VE is 0. Since we don't have any resistor here, this value is 0. So I hope you are getting those equations. And one more equation is, you can say that ICRC as in VCE can be the same as VCC minus ICRC. Using this equation here, so if you use this equation here, you can be able to see that if you take this to the other side, you subtract and you have VCC minus ICRC. Please note that that's the equation you can get out of this. You also have your IC as the current, which you make the subject of the formula from this equation that we have at this point. VCC equals to ICRC plus VCE. If you want to get IC as the subject of the formula, just take VCE to the other side, which means you subtract VCC minus VCE is equals to ICRC. And if you want to get IC only, then you take RC as the denominator down here. So those are the equations that we have. So the base bias with emitter feedback Though I think I would want us to have a look at this case here, and maybe we do an example. Let's just do a small example out of this. So the example we are going to have is, I would want us to calculate if we are given, so given given RB is equals to maybe 500 kilo ohms. And then we have RC is equals to 2 kilo ohms. And then VCC is equals to 10 volts. And then somebody can ask you to calculate IB, calculate IC, calculate IE, and also calculate VCE. But you also have a requirement here. Please take beta to be equivalent to 100. I want you to try that question first before we move on. So are you getting the question, you guys? We are going to use the questions that we have here. Just look at them and you'll be able to see what you can be able to calculate. So I give you around 2-3 minutes. We see whether you can be able to get them. And we start with IB before you go to the others.
IB is equals to IE minus IC. Collins.
Merudi.
Guys, what do you do?
You guys are supposed to discuss. You can discuss, no problem.
Yes, yes, we're discussing.
It's okay. Mimi nasikia tu nikaa watu tu wana.
Collins
Unasema ati IB is given
nasikia
by
tu watu nikaa wanacheka tu, ni discussion wanafanya.
Stratton.
Yeah.
Did you? We have IC over IB, which is equivalent to a beta, and we have the beta given as 100.
Pardon, IC?
IC over IB is equivalent to beta. So we have beta here as 100, right?
Yeah.
See, IB 100. So our IC is, are we given IC? Not yet.
Who is on Galaxy Prime? Galaxy Prime.
It's Brian.
You can change the name to bear your
What?
name. The name of you can change that
Of
name
my
up
name?
there, so that I take. I want to take a register here.
Okay. Should I do it immediately?
There's a way you can change it. Just go to the, I think sometimes settings, and then you change.
Okay.
You guys, you are still supposed to discuss. Please, you can discuss. The way you are discussing, no problem. But I give you time, a bit of time.
VB, VC.
And I think those ones who are discussing already, you are getting it correct. I heard you were talking about IB, IC, and beta, and I think that was fine. Though you could start from somewhere. Please use this equation. The equation of VCC is equal to IBRB plus VBE. I think I should have also given VBE. It's usually a constant, and it's supposed to be always 0.7. If you don't have it, you always assume it is 0.7 volts. So use this equation, this one, to be able to calculate for IB, because that's what you start with.
VCC minus VPE. Wait.
Hey, you guys, you're taking a lot of time. Nobody's getting that IB. So let me do it for you. The first one, and please know that we are using the formula VCC is equals to IB RB plus VBE. Now, from here, what do you think will be IB? If you make IB the subject of the formula, how will it be?
It will be
Is it
VCC
Yes, VCC
minus VBE
minus VBE, that's correct.
No.
over RB?
Divided by RB, that's perfect. That's correct. So what you do next, just substitute the values. You have all of them.
Yes.
So substitute the values and then you get me what you expect.
This is 10 volts minus VB RB.
Should be 4.65.
4.65
times 10
times 10
to power 3.
raised to power
3.
no. It will be negative, but I want to get negative what?
Negative 3.
Is it 1.86 times 10 raised to power negative 5?
Sorry?
That should be the correct figure. It's actually 1.86.
86.
6 what?
86 to power negative 5.
1.86
Sorry,
times 10 to power negative 5. Please note that that's the correct answer. That's correct. Somebody has sent allow me to go offline having
It's
issues.
1.86.
That's okay. So I want to go offline. I think that's fine. Now that you have this one, you can do the others. It's very easy. Please note that you can get IC. IC is very easy to get. That should be the easiest.
I see.
Which formula do you use for IC?
VCC.
IC is equals to beta times can you remember the formula of beta is equals to IC over IB?
Beta times.
So it will be
Beta times
what?
IB.
Yes,
IB.
that's what you're supposed to have. So 100 times this value. And what is that supposed to be? That's also very easy. It should be 1.86 times 10 to the power negative.
Negative
3.
Negative 3, that's correct.
IE.
So, what's IE? IE is also supposed to be very easy.
IE is equal to ICE. It is
IE is equals to
IC plus IB.
IC
C
plus
plus
IB.
IB, that's correct. And if you take the two values, our IC, we have it here. And we place it here, plus
IB, which is 1.8.
Yeah, and we place it here also. So effectively, what is the answer? 1.8686,
Times 10 to the power.
It will be 1.8696. Can somebody confirm? 1.8.
1.86 times 10.
It will be 1.86 something. Yeah, you guys, you have calculators, you can do that.
Okay, I'm getting 1.8786.
Yeah, that should be the correct answer.
Power -3.
So it's
1.86.
1.7.
8786.
It's 1.8.
786.
786 times 10 raised power
-3.
-3. That should be correct. Eh?
Yeah.
Amperes.
1.86 times 10 times 10 power -3.
So I hope every person has got now. You have that. You just add the two values, and I think this is what you get, which is correct. Because this one is added to 7 and then 86. Then we see what's the formula?
Times 10 power -4.
I can see now I have 13 members. One member is the only one which is missing. I have Collins, Mohammed Abde, Stratton, Aisha, Brian, Emmanuel, Ayes, Ian Mayaka, Mercy, Claire, then Samuel Omambia, Mohammed Abdinazir, then I have Abdurai Azan and Ibra Aden. So those are the ones which are present. I've actually taken the register already. Just one person is missing.
I think you have 2 from the day class.
There are 2 guys who have joined from the day class. Reason, I didn't even inform them anyway. Reason, I think we had not gone to this topic. Sorry, anyway, I will talk to them later. Who is from the day class?
I think it's Ian and Aisha.
Oh, so please, with the day class, I think I'll have to hold a different class, because they are a bit behind. Maybe I'll hold a few classes before I can have the 2 together. I think maybe that's what I should have even done from yesterday. But I will organize myself. It's okay. So we see, have you managed to get? Which formula are we supposed to use? This one, This is equals to ICRC plus VCE. Please, by now you should have gotten this, because based on that formula, it will be very easy. Just replace the other parameters that you have, and you'll be able to get. So use the formula VCC. VCE is equals to VCC minus ICRC. Just substitute the values, and we have 10 minus IC is equals to 1.86 times 10 to the power 3. And then you multiply RC. I'd given it to you, it's 2 kilo ohms. So take 2 times 10 to the power 3. and you'll be able to get your VCE. The ones who have calculators, when some guys just came into class, then they disappeared. The two guys, no, but Aisha is still there.
10 to the power of.
So get me the value.
2 times 10 power 3.
6.28.
6.28 volts. I think that should be correct.
Yeah, 6.28.
Because the maximum we can get here is 4. Since this -3 and 3 cancel out, and then we are left with 2 times this should be 2. Then this is 7, and then this is 3.72. We subtract, you get 6.728, which is correct. Yeah. So please note that those are the answers that we get for this connection. And if we have written, I think I can just eliminate this.
Let me take a photo first.
Yeah, please take.
Done.
Okay. So I will change this value to 1 mega ohm. And then I change this to 3 kilo ohms. Then this remains the same, this remains the same, this remains the same. Please, I will ask you to repeat the questions. So take a photo of that one. No, just repeat the same. So repeat the same. Calculate IB, calculate IC, calculate I, calculate VC. Have you taken them?
Yes.
You are just supposed to take an image of the same. And I think we complete that section. So just do that exercise. And I think because of, I can see our time, we are just left with a few minutes. What I'll do is, I will not do another class now. I think this introduction was okay. I'll ask you to go and read the other biases. Please go and read all the other biases. Like the base bias with the meter feedback, you'll be having this representation here, RB, RC, and RE. And then these are the equations. Then I'll ask you, if you take those parameters that we still have, the additional parameter will be take RE is equals to 4 kilo ohms. And then RB, no, take RB also to be, change your RB to be 5 kilo ohms. Then the other parameters are the same. Please repeat that question as we meet next time. Will that be okay?
That's right.
So we'll arrange for the other class. I will organize for it. I mean, we're gonna organize for it with the class rep. Is that okay?
Yes.
Yeah, from the challenges, please discuss about the challenges that you have had today, what we need to improve.